Hello, everyone. Welcome to this final day of the J Champions Conference. We are at the first talk of the day with Grace Jansen. She's going to be speaking to us about thriving in the cloud, going beyond the 12 factors. I was just having a nice conversation with Grace before we started here, and she told me something interesting about herself. Not only is she a developer advocate with IBM, but she actually started with a biology degree. I thought that was interesting to share. So I've been excited for this talk, looking forward to it all week. So I'm going to hand the stage over to Grace Jansen so we can get started.
Thanks so much, Melissa. Really appreciate the kind introduction. It's so great to join you all. I was watching the one last year, and I'm just so excited that I get to join this year's conference. Hopefully you guys are all excited for this last day of the conference. I know there's been so many amazing sessions so far, but hopefully today lives up to your expectations as well. As Melissa said, I haven't always been a developer advocate. I was a biologist, transferred into developer advocacy, so kind of one of the sort of more unusual routes, I would say, into a technology career. But now I do a lot of sort of presenting. I also write articles and blogs and tutorials and lots of other things as part of my advocacy within IBM, mostly focusing on sort of cloud native Java and lots of open source technologies and software. So today I'm going to take a closer look into sort of how we can really enable our applications to not just sort of barely survive in the cloud, but hopefully to thrive in that cloud environment by going beyond the original 12 factors. So without further ado, I'm going to get started. If you have questions throughout this session, please feel free to put them in the chat as we go along. I'll do my best to keep track of them. If I can't answer them whilst we're going through this presentation, then I'm going to leave some time at the end and hopefully get round to all your questions then. If there's anything you think of afterwards, or you're just interested in finding out more, feel free to connect with me at Twitter. My handle is on the screen on most of these slides, but it's at GraceJansen27. Feel free to reach out there. So first things first, why do we even care about this topic? Like, why are we bothering? And it's because we get excited when we hear about the cloud, when we think about moving our application onto the cloud. It's a bit like, ooh, the cloud. Hopefully you've all seen Toy Story. If you've not, please add that as homework because it's an awesome movie. But basically it's this excitement of what we can achieve by utilizing that cloud native infrastructure, how we can enable innovation and advantages and benefits within our application by making use of it, by ensuring our applications are really thriving and effectively utilizing all of that. Some of the benefits that the cloud can offer us include some of these things like reduced cost, for example, scalability, often dynamic scaling, not just up, but also back down again, relating to that cost effectiveness, having speed of release and delivery, resiliency, flexibility, innovation, like I mentioned, being able to take advantage of new features, new products, new platforms, and innovate, not just within our applications, but use that innovation in the cloud. And fashion. It might not be something you immediately think of when it comes to application development, but being able to take advantages of the latest and greatest trends in application development is something that the cloud can help to offer as well. And actually, I took a look at a bunch of different vendor-specific and also other definitions that were out there around what does it really mean for an application to be cloud native. And I took all of these definitions and I got rid of all of the terms that were platform specific or language specific. And essentially I came up with this word map that looks a bit like this. And this was essentially the important factors of being cloud native that enable us to be able to achieve those benefits. So having observability, for example, having loosely coupled elements to our application so they're not tightly coupled and highly dependent on each other. Being able to rapidly scale, being resilient, again, having that speed in there, robustness, all of these key sort of applicable behaviors are what we want to achieve to build cloud native apps. That's what we get excited about, to achieve those potential benefits. But how do we actually go about being able to achieve these very abstract behaviors and characteristics? And that's where methodologies can come into play and be very helpful in guiding us as we're building or transforming our applications to be cloud native. And one of the most common of these is the 12-factor app methodology. If you've not come across this before, then definitely check out the 12factor.net, which is where you can see much more in depth into each of these factors. and sort of why they were introduced in this methodology in the first place. Now, the nice thing that I like about this methodology is that it's platform and language agnostic. So it can be applied pretty much to any application wanting to sort of go on that journey to becoming cloud native. And it lays out, as the name kind of suggests, 12 factors that help you really from end to end in your application create those cloud native characteristics and behaviors and make them innate within your application. So the original 12 factors are listed here on this slide, and we'll go through these in a bit more detail, but hopefully a lot of you will already be familiar with them and some of the technologies that I'm going to go through that can enable each of these factors. Now, the technologies I'm focusing on in this particular presentation are all pretty much open source technologies that you should be able to take advantage of, given the fact that they are open source and freely available. So hopefully everyone can be able to pick up some new technologies within this presentation today that they can actually make use of in their own applications, or at least try out to see whether it would be helpful for you. So we're going to take a closer look into each of these, but I firstly wanted to point out how this original 12 factors differs from the extended 15-factor app methodology that I want to go into in further detail. So here's the original 12 factors, and here is the revised edition of that. The 12-factor app methodology was created almost a decade ago, and although it was a fantastic sort of starting point, our cloud-native infrastructure, our application development, just our general awareness of building cloud-native applications has moved on since then. So it makes sense that sometimes these methodologies are going to need updating and revising. So Kevin Hoffman from Dynatrace has actually written a book, and this is where the 15 factors originates from. And if you want to check that book out, I've included a link here in this slide. For any links in my slides, I will share my slides afterwards. So don't panic and feel like you have to write it in yourself. You will be able to access all the links yourself afterwards. But yeah, so he created this sort of revised edition, and you can see that some of the, for those who are keen-eyed, you can see that some of the original factors are there, but they've had some slight tweaks or revisions. So for example, instead of one code base in the original 12 factors, it's now one code base, one application. And we'll be looking at this sort of revised version of them as we go through each factor. Now, I'm not going to make you try and go through each of these and guess which ones are the new ones. I've made it easy and highlighted them for you. So these three factors here, API first, telemetry, and authentication and authorization, are the three additions that have been added on top of the fact that he has made some revisions to those original 12 factors. And we're going to deep dive into each of these once we've sort of skimmed through the first 12 factors and deep dive into why these were added, how they make a difference, why they're important in cloud native development, and how we can achieve them, again, with open source cloud native technologies. So bear with me as we go through the original 12 factors, then on to the 15 factors. And then at the end of this session, I'm going to show you using a code demo how easy it can be just to try out or add some of these technologies into your existing application to enable some of these additional factors. So without further ado, I'm going to quickly skim through the original 12 factors and then go on to the additional factors that I just mentioned. So the original 12 factors. The first of these is one code base, one application. So this really refers to the fact that there should be a one-to-one relationship between an application and its code base, but a one-to-many relationship between its code base and the different deployments you might have, whether that's production, staging, QA, DevSecOps, whatever it might be, having many of those coming from that single code base that we mentioned. And that's why there was this revision from just code base to this extended name, one code base, one application, really sort of focusing down on that specific one-to-one relationship and then the one-to-many. And this is really a factor that's been included in this methodology to ensure that we have sort of collaboration between development and different teams, to ensure we have proper versioning, and to enable us to have faster time to market. Now, how do we go about enabling this factor? Most of you are probably already using a lot of these technologies, or at least one of them, but using Git repositories can really help us to have that single source of truth when it comes to the code base for our application. You might be using something like GitHub, GitHub Enterprise, GitLab, or alternatives like Bitbucket, Launchpad, AWS Code Commit, whatever it is you're using. Git commits can really help, Git repositories can really help to enable us to have this sort of one-to-one relationship. So that's the first factor. The next one is dependency management. So in a sort of classic enterprise environment, we're kind of used to this concept of a mummy server. And this server acts like a mum. They provide everything that our application needs and takes care of their every desire, whether that's satisfying our application dependencies, providing a server in which to host the application. But as the cloud has matured, our applications have also had to mature and basically grow up. Our applications can't be reliant on these mummy servers anymore. They can't assume that a server or application container will have everything that they need. So instead, our applications have to bring with them their dependencies and ensure that we are essentially listing out everything that we could possibly need within our application. So this factor is all about explicitly declaring and isolating application dependencies using things like declaration manifests that can be stored within your code base, or using things like dependency isolation tools during application execution. So why is this important? Well, it helps to provide consistency between the different environments or deployments we might have. It helps to simplify setup, especially for developers who might be new to our application. And it supports portability between cloud platforms, because you've got all of your configuration in one place. You can easily adapt and change that depending on wherever you're deploying your application to. And it helps to enable greater developer productivity. How do we go about achieving this one? Well, again, you're probably using many of these tools already, whether that's Maven or Gradle or something like Ant, for example. These can help us to explicitly declare and isolate our dependencies and sort of package them up in these third-party libraries. So utilizing things like a Maven pom.xml file or a Gradle settings.gradle file. And these enable us to really freely either move up to newer versions or explicitly declare specific versions or change those versions depending on where we're deploying our application to. So that's the second of the original 12 factors. The next one is design, build, release, run. Now, in the original 12 factors, this was just build, release, run. In the revision, design has been added in really to sort of make it clear that unlike maybe more traditional waterfall style methodologies of creating applications, we are very much in an agile world, and that design sometimes has to be changed or iterated upon as we build and release and run our application. So it needs to be included in this cycle. So really, this is all about this factor is about strictly separating out those different stages into design, build, release, run to prevent changes to code and or configuration at runtime. Basically helps to lower the number of unexpected failures we might have. It helps us to enable a more effective release management and enables that maximum delivery speed, while importantly, keeping high confidence through things like automated testing and deployment. So enabling us to have high confidence that our application is going to work as we intended it to, because we've got this strict separation and this automated release management. So how do we go about achieving this? Well, this is kind of some of the factors it's important to note aren't necessarily sort of one-to-one directly related to a specific technology or feature or API. Sometimes they're more about the individuals who are designing the applications or building the applications and their behavior. And this is kind of one of them, because this is really a methodology or a practice thing for people and organizations rather than specific technologies. However, you could use things like, for example, an automated CI/CD pipeline using tools, for example, like Tekton. So these tools can help us with these methodologies. Another one of the original factors was configuration. Now, this has been extended to be configuration, credentials, and code. And this is really again, most of these revisions are about narrowing down that focus, about being more explicit about what is this factor really about. And this is really about not just configuration, but also specifically separating out your configuration and credentials from your code. So configuration can refer to sort of any value that can vary across deployments. So whether it's your developer workstation or production environment, it can include things like URLs, other information about backing services, information necessary to connect to databases, or credentials, for example, to third-party services. Credentials, importantly here, have been pulled out and specifically given a mention because they are, I would argue, one of the most extremely sensitive pieces of information that have absolutely no business being in a code base. I think we've all learned from the recent security issues that have been happening in the last few years, like Log4j, Log4Shell, the fact that we do need to be thinking about security all the way through our development, including when we're separating out configuration and credentials from our code base. And this is an important step in that security. So it should be obvious, really, why we wouldn't want to have credentials in our code. It's also important to bear in mind this factor is also kind of trying to reiterate to developers that we should be following this golden rule of developing microservices is really about sort of writing it once, but configuring it everywhere. So instead of having to go into each individual class within our application, within our microservices, and changing each time we utilize a specific configuration value, instead we can just separate that out and change it in one place instead of having to change it in every single class. So this factor is about having that strict separation between code and configurations and credentials and storing them in environmental variables. Why is this important? Well, again, I mentioned about the security aspect already, but it allows us to modify our application behavior without having to make specific code changes, only configuration changes. And it also helps to simplify our deployment if we're deploying to multiple different environments, and it helps to reduce that risk of leaking any credentials and passwords that we might need to be using. So how do we enable this? Well, first things first is you as developers need to be extracting all application configuration to environmental variables. And we can use, for example, microprofile to be able to enable us to do this. If you've not come across microprofile before, there is a talk later on today by Emily Zhang, and she's going through the latest microprofile release, which I believe is 6. And she's going into that in a lot more detail. So please go and check out her talk later if you're interested. But essentially, it is an open source, community-driven specification that enables Jakarta EE or Java EE applications to take advantage of developing microservice-based applications. So it enables a wide variety of different APIs that are designed for cloud native and for microservices. And one of those APIs is microprofile config. And what that enables us to do is place our configuration in a properties file that can essentially be very easily updated without needing to recompile our microservices. So I've linked here to one of the guides. It's what I'll be using later for my code demo. So if you're interested in any of the technologies I'm mentioning throughout this presentation, I've included links to each of the relevant guides that we have for you to check out if you want to go back afterwards and have a go yourself. Next one up is logs. Now, this factor is really about sort of treating logs as event streams. So reiterating the fact that we should be logging to stood out or stdr only, and the fact that really a truly cloud native application should never have to concern itself with routing or storage of its output stream. That should be a platform responsibility. So why is this important as a factor to be included in cloud native methodologies? Really, this is about making logging, as I mentioned, a platform concern, not a developer concern, and improving flexibility for sort of introspecting behavior over time. It enables us to collect real-time metrics to be able to analyze that and understand how our application is behaving. How do we achieve this? As I mentioned, you can log to stood out and stdr only. You should be treating logs as event streams, and you should be considering things like the aggregation and processing and storage of your logs that should be satisfied not by your application, but by your cloud provider or some other tool suite running in cooperation with the platform that you choose to use. So some of the technologies that you might use for this include things like Elk. So the Elk stack consists of Elasticsearch, Logstash, and Kibana. You might use something like FluentD, Splunk, Sumo Logic. There's a number of different tools that can help you to capture and analyze your log emissions to really learn from that behavior over time. So this is a really important factor in terms of understanding your application as it's sort of running itself. So then the next one is disposability. This is a bit of an abstract image, so bear with me with this one. But essentially, this factor is all about maximizing the robustness of your application by ensuring you have very fast startup and graceful shutdown of microservices or resources within your application. And this is where the image comes into play. It's about treating our resources more like cattle and less like pets. So I've got an example here with my diagram where I've got some cows on the left-hand side. Now, if, for example, one of them were to get sick, sick to the point where it would take a lot of money, a lot of resources, a lot of time to nurse them back to health, the likelihood is they're cattle. I'm probably just going to, unfortunately, put the cow down and then replace it with another cow into the herd later on. Whereas with a pet, I have Carl the cat here. And with a pet, what tends to happen is we get emotional attachments, we name them, we care for them, and when they get sick, we nurse them back to health. It takes time, it takes resources. They might be sort of not functioning like they should be during that period. And essentially, this is what we want to be avoiding, this mindset when it comes to our microservices. We need to be able to very gracefully and quickly shut down resources that are not performing and be able to replace them with effective resources instead. So having this sort of cattle mentality when it comes to our resources in our application. This is how we can enable ourselves to be resilient and highly responsive in the cloud. Why is this factor important? As I said, it enables fast, dynamic, elastic scaling. It allows us to sort of have rapid deployment of things like new code or new configuration changes, and ensures that robustness in production deployments. How can we enable this factor? Well, firstly, we need to be minimizing work on startup, so don't depend on things like shutdown hooks. And we need to be maximizing our robustness with fast startup and utilizing things like automatic scaling. And for this, we can utilize things like, for example, microprofile fault tolerance. This is another microprofile API that you can make use of and allows us to build in behavior for what should occur if something were to go wrong within our microservice, if a fault were to occur. So this can be a really useful API to make use of to ensure that we're sort of enabling the correct behaviors when we need our resources to stay responsive. The next one is backing services. So backing services, really, this is a really broad term and kind of deliberately so. This is any service on which your application relies for its functionality. So it might include things like data stores, messaging systems, caching systems, really any number of service that sort of perform line of business functionality or security. So this factor is all about treating those backing services as bounded or attached resources. And what I mean by that is really sort of a means of connecting your application to a backing service. Sort of a resource binding for a database might include something like a username, a password, and a URL that allows you to be able to consume that resource. But importantly here, there should never be a line of code in your application that tightly couples the application to a specific backing service, because that backing service might need to change at any moment. So there should be no distinction between a local or a third-party service. They're all backing services, and they should all be treated as bounded or attached resources. And you should be attaching those resources using things like URLs that can be stored in an application's configuration. Why is this important? Well, it helps to provide that loose coupling that was one of those big words back in the mind map I showed you at the beginning. So we don't have that tight coupling between elements of our application. And it means that you don't need to have any code changes required to be able to update a backing service. It also allows operators, for example, to automatically swap out as they see fit the backing services. And as I mentioned earlier, this is enabling that resiliency and agility, the possibility to attach and detach bound resources whenever you need to. So really enabling those key characteristics and behaviors of cloud native. How can we enable this? Well, really, it's about treating backing services as attached resources. And again, we can utilize, for example, microprofile config to be able to do this by having that separate configuration file. The next one is environmental parity. Now, this was originally dev prod parity in the original 12 factors. It's been widened this time instead of narrowed. So this is one of the few factors that has been widened in this revision. And this was really to include the bunch of other environments that we might have, the bunch of other deployments, whether that's DevSecOps, QA, whatever it might be, staging, for example. We have more than just development and production. So it was to include all of these different environments in this parity, in this factor. So this factor is all about trying to keep these different environments as similar as possible. So really applying discipline to our environmental parity to make sure our team and our entire organization has the confidence that our application is going to work the same in every environment. And really, this is important because it helps to lower risks of uncertain areas that we might miss in development that crop up in production because we've got a different tool in there or a different environment of some kind. And it helps to support that continuous deployment and enable greater reliability. So how can we enable this factor? Well, the first thing is we need to ensure that things like, all our backing services are the same that we use for all our deployment. If we can, ensure that we have a solid continuous integration pipeline and deploy to production as often as we possibly can. Now, an automated CI/CD pipeline, like I mentioned before, could possibly help with this, but we can also consider other tools like, for example, containers, because when we're deploying to the cloud, we're usually deploying in containers. So it makes sense to be able to utilize containers on our local machine to be able to replicate that production environment. And we can use tools, for example, like microshred testing or test containers to be able to replicate that production environment in containers on our local machines to test our application so we can find those bugs and errors before we deploy to production. So these can be really helpful open source tools that you can utilize. And again, we have a guide for this if you're interested in trying it out yourself. Administrative processes is another of the original factors. We've only got a couple left of the original factors, and then we'll be moving on to the new factors. So this is really about running any admin or management tasks that you might have as one-off processes and storing the code for those tasks within the app's code base. So this can include things like one-off debug tasks, for example. It's important because it's really about safely debugging or doing the admin of production applications, and it enables greater reliability. How can we enable this? Well, Kubernetes tasks is one way that we can enable, we can use this to be able to enable this. Or alternatively, if you want, you could use things like lambdas, like, for example, AWS lambdas. The next one is port binding. So this is really about sort of enabling that ops efficiency. So this is about asserting that a service or an application should be identifiable to the network, not by a domain name, but by a port number. And this should be really managed by the cloud. So this is another one where we're moving the responsibility away from development to the cloud provider to be able to sort of maintain it, scale it, ensure routing is correct for it, and fault tolerance, all of which sort of the cloud provider should be managing. And this is important, as I mentioned, for ops efficiency. And the reasoning is really that the domain name and associated IP addresses can be assigned on the fly by manual manipulation and automated service discovery mechanisms if we need them to. So how is this factor enabled? Well, first things first is export services via port binding. And we can, again, use things like microprofile config to be able to help us do that. We can specify, for example, the new port in a Kubernetes config map, and microprofile config can automatically pick up that value to give the correct information to the deployed microservices. So we can use a combination here of microprofile and Kubernetes for our application to enable this sort of automated changing of things like port names. Then we got stateless processes. So stateless processes is really about the fact that microservices, if possible, should be stateless. This is about executing our microservices as one or more stateless processes and ensuring that all of our stateful data is stored in a backing service of some kind. Now, this is really to reduce deployment complexity, operational complexity, and allow for much simpler scaling and cross-cloud compatibility. How can we enable this one? Well, as I mentioned, store data in a backing service of some kind. Don't use things like sticky sessions or the local file system. Don't use in-memory caches. Really, this is about sort of, as I said, storing data in backing services if we can, treating them as stateless processes. How can we enable this one? Well, I've kind of mentioned already some of the techniques you can use, but we can also use tools, for example, again, like microprofile REST, or we can use things like external third-party caching products. So Gemfire is one, Geode is the open source version of that, Jcache and Redis. All of these are designed really to act as that backing service cache for your applications. And again, we've got a couple of guides that you can utilize to get hands-on with these technologies. And the last one is concurrency. So concurrency, this is really about advising us that our application should be able to scale out using the process model. So there was a time previously when if we had an application that was sort of at the limit of its capabilities, the solution was just to increase its size. So if an application could only handle a certain number of requests per minute, then basically we just made the application bigger. So we'd add CPUs, RAM, and other resources to a single, pretty much already massive monolithic application in what we call vertical scaling. This type of behavior is generally typically frowned upon within our society these days, a much more modern approach, and one that's kind of ideal for the elastic scalability that we want within the cloud, is to scale out horizontally instead of vertically. So rather than making one single big process even larger, you create multiple processes and then distribute the load of your application among those different processes. So being able to scale up microprocessors independently depending on the workload that you have on your application. This allows for very easy horizontal scaling and auto scaling. How can we enable this? Well, we need to be splitting our application into separate runnable processes and be able to scale those independently. We can use things like, for example, Kubernetes Autoscaler to help with this. So that was my super quick run through of the original 12 factors. And now I'm going to go into a bit more detail on the additional 3 factors that have been added in the 15-factor app methodology. So the first of those was API first. Now, again, as I mentioned before, some of these factors don't necessarily map to specific physical requirements imposed by the cloud. Some are more about the habits and behaviors of people and organizations that are actually designing and building those cloud-native apps. This is one of those factors. So this factor is all about giving teams the ability to work against each other's public contracts without having to interfere with the internal development processes. It's about having this sort of API-first approach of the API being a first-class artifact in your development process. So what you're really building is an API that's going to be consumed by client applications and services. Why is this factor, why has it been added? Why is it important in cloud-native development? Well, it helps to avoid things like integration failures. And as I mentioned, it formally recognizes your API as a first-class artifact in your development process. It enables greater collaboration with stakeholders because you can spend time before investing tons of resources into creating an API. You can actually spend time designing with stakeholders collaboratively what they need from each API or service. And it enables you to sort of take that sort of brainstorming and that designing session and fully understand your API to be able to create greater documentation and the ability to be able to mock up that API first before putting in too much time and energy and resources into making something that isn't right for your stakeholders. And it enables you to sort of test and vet your direction, as I said, before investing too much into it, enabling you to have greater flexibility when it comes to that design. How can we enable this factor? Well, the first thing is we have to be mindful that we are participants in this sort of ecosystem of the cloud, because our service is probably going to be reliant or be used by someone else within the cloud. We have to be mindful of the fact that we need to be sharing these public contracts for others to be able to clearly know how to use our services or our microservices and interact with us. We can utilize things, for example, like open source specifications. So there's a couple out there we can use, like OpenAPI or API Blueprint, which enable us to sort of have this common language to be able to describe our APIs and how to use them. We might also use proprietary products like Apiary or IBM's API Connect tools if you wanted to use proprietary instead. And MicroProfile has the OpenAPI as one of its APIs available, and that actually makes use of the OpenAPI initiative. And this is what I'm going to show in the guide today. I'm going to show how you can utilize MicroProfile OpenAPI to be able to add this documentation into your application so people can clearly understand and interact with you in this ecosystem. So this is what I'm going to show later. Interestingly, this was actually originally based on the Swagger specification, but it has been donated as open source. So you'll notice there's like a Swagger UI that I'll use in the demo, which is also open source that we utilize. The next one that was added was telemetry. So you might be questioning, for those who have been paying attention throughout this entire talk, well done if you have, is telemetry, you might be thinking, why do we have this factor included? Why was this a necessary addition when we already had logging in the original 12 factors? And it's a valid question, but my argument would be that although logging is a really good start, generally it's a tool that you use during development so you can diagnose code errors and code flows, and logging is typically orientated around that internal structure of your app rather than reflecting the real world customer usage when it's sort of released into the wild. So basically, logging is how you collect data about your app in the lab, whereas telemetry is how you collect data once the app is released into the wild. So the concept of telemetry has been introduced here to really capture that difference and to understand how our application is behaving in production. So when it comes to monitoring our application in the wild, as we'd say, there are a few different categories of data that we might want to collect. It includes things like application performance monitoring. So that might include things like number of HTTP processes per second. We also have things like domain-specific telemetry. How many products did we sell in the last 20 minutes, for example? Or we might be looking at health and system logs. So checking your system health over time, getting event information like start, stop, scale, etc. And this has been introduced, this factor, because modern applications are a lot more complex than perhaps they used to be. These applications are and supporting environments are composed of sometimes hundreds of microservices that are highly dynamic, they're distributed, they have to scale automatically to meet users' needs. This is a complex environment, so we need to be monitoring it carefully to understand how it's behaving. So it's more important than ever that we have a clear idea of how our applications are behaving, especially when so many of our applications are mission critical and need to be performing at peak performance all the time. So how do we achieve this factor? Well, we can utilize sort of telemetry tools, and some of the microprofile ones we can utilize are health and metrics APIs. So this allows us to, the health basically allows us to determine is our application healthy or not? Is our microservice healthy or not? And do behaviors based on that information? So if it's not healthy, perhaps bring it down. Going back to that disposability factor, being able to gracefully shut it down or restart it. And then metrics allows us to collect a whole host of important information about how our application is behaving. So that's the second of the additional factors. And then the last one is authentication and authorization. I was super surprised when I read the 15-factor app methodology and reflected back on the 12-factor, because I hadn't noticed initially, but actually in the original 12 factors, there's no discussion of security or authentication or authorization, which is very surprising given the fact that it is so important in cloud native development. Security is a vital part of any application in cloud environment and should never be an afterthought. So it's a vital addition to this app methodology. Your code, whether it's compiled or raw, when you're deploying to the cloud, is transported across sometimes many different data centers. It might be executed within multiple containers or accessed by countless different clients, some legitimate, some not so legitimate, kind of nefarious sometimes. So really, we want to be securing our applications. In an ideal world, you'll be using things like RBAC, and that stands for Role-Based Access Control. So for every request for an application's resources, you should know who is making that request and whether that person has authorization to be able to access that particular functionality. Why is this important? Well, this is all about adding security, which I think we all know is vital in our applications. How can we do this factor? Securing endpoints, like I mentioned, using RBAC. And we can utilize tools, for example, like OAuth 2, OpenID Connect, KeyCloak. There's a bunch of others that we can utilize to enable us to do this. Within microprofile, we can make use of the JWT API. This is JSON Web Tokens. And this allows us to essentially store tokens to understand who the user is that's trying to access this particular application or microservice, and enable us to authenticate and authorize and verify that user. So JWT is a really great tool to be able to use for this factor. And that's the last factor in that 15-factor app methodology. And when we actually apply this to sort of a generic, I guess, mapping of how you create applications and deploy them, so we can actually start to see how they enable those behaviors that I mentioned right at the very start of this presentation. So going through it, we have sort of this arrow that indicates sort of loosely our delivery pipeline from the left to the right. And then we have the deployment environment that we're deploying our app into, whether that's a public or a private cloud. And when we start mapping on these 15 factors, we can then start to understand how they can enable some of these behaviors that we want to be achieving to be able to achieve the benefits of the cloud and essentially thrive within this environment, like scalability, rapid deployment, resiliency, loose coupling, and observability. And as I mentioned, there are lots of different cloud native tools that you can utilize to be able to achieve that. So I've not gone long left, so I'm going to quickly show you how you can get started with some of the technologies that I've mentioned. All of the ones I've mentioned have been open source, so you should be able to get hands-on with them, try them out, and see if they'd be useful for your own application. And for this, I'm going to be making use of this interactive cloud native environment we created. So you won't need to have any prerequisites on your local machine. You can just use a browser, preferably Chrome or Firefox, but it should work on most browsers, and it means you don't have to have any local prerequisites. It will look a bit like this, and I'll show you this environment in a second, but we've got instructions on the left-hand side, an IDE based on Thea on the right-hand side, and then a terminal as well. So you've got everything you need within this environment. The way that we access this is going to the OpenLiberty website. So OpenLiberty interoperates and is a sort of implementation of many of the specifications I've mentioned throughout this presentation. It's open source as well. So if you want to check it out, feel free. It's a cloud native runtime that can enable you to make use of these technologies. And this is where we have all of the labs that you can try out for yourself. To access it, you just need to go to openliberty.io and then hit the guide section. So I'm going to quickly switch over to, it's logged me out. Okay. So I'm going to quickly switch over to the OpenLiberty website. So hopefully you guys can see this. Yep. So on here, you can look through, we've got 41, I think we've got 50 something, 60 something guides. So loads of different ones to choose from. The one that I was going to give a go today was the Open API guide relating to that first and additional factor that I mentioned. So I can use the search functionality to be able to find it. And it's this documenting RESTful APIs one here. It will take you to a page like this. If you want to do it locally on your own machine, you can. You'll just need to bear in mind that you need these prerequisites on the top right-hand side, and you can just scroll through the instructions to be able to follow along with the guide. However, like I mentioned, we're going to be doing it in the cloud option today, which should give us access to be able to have access to that online environment to be able to do it all there. It will ask you to log in and confirm that you're not a robot. We had some issues when we weren't logging people in with people Bitcoin mining, so we apologize for the extra step, but it was necessary, unfortunately. And as I mentioned, on the left-hand side, you'll have this sort of these instructions that will take you through. And then on the right-hand side is that IDE that you can make use of. So I have, let's have a look. Fantastic. So it's already kept all of the stuff that I did before. To speed up me showing you this demo, I've already gone in and I've already cloned down the repo that I need, which is openly available on GitHub. So if you do want to check it out, feel free to go over to our GitHub page and look at the code for yourself. But essentially, I've already done these Git clones and have already started it up using Liberty Dev Mode. Dev Mode allows us to be able to sort of hold our command line session and listen for any file changes or configuration changes we might be making to our application. So it's essentially like hot reloading. So instead of having to tear down our entire application, we can automatically see changes that we make when we save our files. So I've already got that successfully running in dev mode, as you can see here. So I'm skipping these first few pages just in the interest of time. You'll see here in my Explorer mode, I can see the file structure that I've got. For each of our guides, we have a finish and a start directory. Finish is what you'll achieve at the very end of the guide. Start is what you're starting out with, as the name suggests. So if you run into any issues or errors when you're actually doing this demo or any of the guides that we have, it can be useful to refer back to the finish directory to see the differences, whether you've just made a typo or something like that, or whether there's a bigger error that's going on. So in this one, what we're going to be doing is adding in some of those open API documentations to enable us to be within that ecosystem in the cloud and be participants and allow people to understand, what does my service do and how do I use it? So to do this, we're going to firstly take a look at the basic skeleton that's created by Jakarta RESTful Web Services framework that we're already using. So because we're using this Jakarta RESTful Web Service, we already get a basic API generation, sort of the skeleton API tree. So to check that out, I'm just going to execute, I need to do a new terminal. I'm just going to execute this curl command. And as you can see, I'm going to make this a little bit bigger. As you can see, I get some very, very basic information back, but at least I get something. It's that basic skeletal API tree, understanding what APIs there are that I can make use of. But I don't really get much of a description. All I get for description is okay and response 200. It's not particularly helpful. Now, to also see it, we could also open up this Swagger UI that I mentioned if you want to see it in a more visual format. This allows us to see it, as I mentioned, more visually. So we can open those up and see the information in the same information, just in a different manner. So going back to my lab, what I can do is actually augment the existing skeletal API tree with Open API annotations using microprofile Open API. So for this, I'm going to open up inventory resource.java. I'm going to make this a bit smaller. And essentially what we're doing here is we provided all the code you need on the left-hand side in the instructions. So we can just scroll down, copy it, and paste. Some of the ones that we're using in here, some of the annotations includes things like API response schema, operation, and parameter. And we've given some definitions of what they do here on the left-hand side. There are loads to choose from, so head on over to the microprofile Open API documentation to see the full list of annotations that you can make use of. Because we've already started OpenLiberty in dev mode, what we can do is it will automatically recompile. As you can see, if I scroll down to the very bottom, you can see that our application has already updated based on that code change that I made. So now what we can do is head back to the other tab and essentially do the same curl command to see the differences in our API tree. So again, if I make this larger, what we can see now is I've got a whole lot more information about my API. I've got a summary so I can understand what this API does. I understand what parameters I need to be able to utilize that API. So this gives me tons more information when it comes to actually making use of this without having to deep dive into my code to understand what's going on. So this can be really helpful additions. Now, this lab continues with adding it to some of the POJOs that we have in there. And it also shows how you can utilize other things like, for example, using searches to be able to, using filtering to be able to filter out specific elements within your Open API tree. So if you want to continue with this guide and see how you can continue adding more information, making your API clearer, using this API tree, using microprofile Open API, then please, I would invite you to try out the rest of this lab. But hopefully what I've shown you is how to make use of the tool and how easy it can be in just a few steps to be able to add in information that can really help when we are deploying applications that are designed to be cloud native. So I know that I've only got 10 minutes left and I want to make sure that I have time for questions. So I'm going to stop. Actually, I'm going to go back to my slides just so I can finish the presentation for you guys. So in summary, hopefully what I've shown you is that the 12-factor applications are a great start, but that to actually thrive within the cloud, we have to be looking beyond those original 12 factors. And we need additional revisions and additions to those original 12 factors. And I'm sure over time, we'll need additions and revisions to the 15-factor app methodology as we learn more and as we develop that underlying infrastructure. And unfortunately, there are no excuses for trying this out. I've mentioned loads of different open source tools and technologies that are available to help, including thriving communities that are there to help you use them as well. So there aren't any excuses for not giving this a go. And an action that I'd love you guys to take away from this is to evaluate your own application against each of these 15 factors and consider what you could do to enable your application to truly thrive within that cloud environment and not just survive. If you'd like some further resources, as I said, I'll be putting these slides up online. So I've got some useful resources for each of the different sections that I've mentioned. Some general ones, they are probably the most helpful in terms of having a summary because they summarize the 12 factors and the 15 factors and give you a great sort of PDF as well. Then we've got some individual resources for some of the factors that I've mentioned throughout if you did want to check them out. And if you are interested in finding out more about the OpenLiberty tool that I've mentioned, then please do connect with us on LinkedIn and Twitter. I help run these, so I'll say hi if you come connect. And it will give you a bit more information about some of the other, we try and share information about those underlying open source specifications that we also implement. So with that, I'm going to say thank you so much for spending the time to be here with me at this session today. And hopefully you enjoyed it. And as I mentioned, I'll take questions now, but if I don't get around to them, my Twitter handle is @GraceJansen27. Feel free to reach out there and I'll get around to any questions that you might have. Thanks so much for listening, guys.
Grace, this was an amazing presentation. I really enjoyed it, really enjoyed listening, and I was nodding my head the entire time, thinking about jotting down some points that you made. I think what we need to remember, and I'm a longtime developer, these are hard fought items. I mean, these are all coming from people's experience of doing the wrong things and going back and analyzing them and then making the changes necessary. So your last point about, taking the applications you have and go compare them against these factors and just see where you stand. I think it's really, really good advice. I've done that in the past and have found myself needing to learn a few things to move forward with my applications.
Absolutely. I think we just get so just fogged into this is the development I'm doing, this is what I'm focused on. Whereas sometimes we need to take that step back, like you mentioned, and evaluate our applications.
Exactly. So really good points. Few things. We have one question, and then I just jotted down a few discussion points that I really want to chat with you about. I think they're great. Most are just comments on how wonderful your presentation was. But, so one question we had, is there any other tool other than Swagger that we can use to define the API? Do you know of anything else that people use regularly?
So in terms of defining the API, the Swagger one is obviously, it was Swagger, whereas it's now open source. So that's why it's the Open API initiative. And MicroProfile Open API is an implementation of that specification. So that's the one that I've shown within my demo there. That's the MicroProfile one. And that's why I use things like annotations. MicroProfile APIs are basically all based on annotations. So the nice thing is once you get started with one MicroProfile API, it's kind of easy to pick up the others because it's a similar process and similar structure in which you follow. So I would recommend the MicroProfile API implementation. Whether there's others, I believe there are others I can look up, but that's the one that I'm most familiar with.
Cool. Very good answer. That goes along with what you said. There's no excuses. There's a lot of open resources out there for you to use and learn
tons,
from.
Yeah.
So we just need to work on getting ourselves educated on those and making the argument that we need time to do that as well.
Yes.
For a developer and a team. Loved your cow and cat slide.
Thank you.
Not getting attached to your resources. That was something I learned early on when I was initially just beginning in this microservice world. And I fell into a lot of those same traps, like putting state into a microservice, realizing after too late designing an API that maybe this isn't a single service, maybe this should have been two, things like that. So what would you say about a project like this? You have this idea of what your application is supposed to do. How much time do you think, if a full project from beginning to end is 100%, how much of that percent should be planning?
This kind of goes back to the whole, the revision that was made in the design, build, release, run. In that planning, I would say, comes in that design phase as well, because it's not just the design of this is how it's going to look. It's about, okay, how are you going to implement that? What are you going to use for it? How are you going to break it up? And that design/planning phase doesn't just happen at the beginning, because we don't develop waterfall anymore. So I would say that in terms of percentage-wise, it really depends on how long your application takes to develop, how complex it is, a million other different factors. Because if your application is going to take, 2 years to develop and build, let's make an exaggeration here, then over those 2 years, how much is technology going to change? How much of your design is going to need to change based on that? So depending on how long it takes you, depending on how complex your application is, that percentage of design/planning is going to change, because it's going to need to keep changing as you keep developing and iterating. But I would say that at least, I'm going to guess about 20 to 30% needs to be planning and develop, and just stepping back and thinking through before you jump straight in, because it's such a vital, you're going to waste time if you don't spend that time doing this important designing and planning. And that needs to be iterative. That can't just be, okay, I'll spend 20 days at the start doing it and then get on with the rest for the 80 days that I've got to do this. It should be throughout, and it should be an agile process as you go along, I would say.
Love that answer, because you're exactly right. You're never done. So they're really coming at it like that with a percentage of how much planning, how much until you're done. That never happens. It's the wrong way to look at it. You can't say a software project is only going to last 5 years, and so you're going to spend the first 20% of that time planning. That's not how it works. All right, cool. Good answer. Loved what you said about test containers. I always have, been in situations where yes. And, just making sure that your development environment is as close as possible to a production environment. So many times we waste time developing something, realizing, oh, this isn't really going to work in our production environment.
Exactly. The number of times I see people who are like, oh, but we're using this because it's really easy to be able to develop on, but actually I need the reliability and robustness of this product because it's better for production. It's like, yeah, but if you're using different stuff, there's going to be different errors.
Yes.
So, being able to have that consistency is so important.
Yes. Whenever you hear someone say it should work the same, you should have your
alarm bell.
Yes. Spidey sense needs to get into action there. Yeah.
Totally.
Databases, I think I've run into that most of the time. So very, very easy to use, like an in-memory database to make your tests fast. But in reality, when you're actually, working with a product, you need to use the same database you're using in production. So test containers allows you to do that. So
I would 100% recommend people checking that out, because it is a fantastic way of ensuring that more production-like environment, and they have a bunch of different modules that you can connect into depending on what tools you're using, depending on what database style you're using. There's tons of different sort of compatibility that you can make use of.
Awesome. One other question just came in. Are you using any specification for generating the service boilerplate code? Is that microprofile?
Yeah, microprofile. So microprofile REST client, for example, is fantastic to make use of. But that sort of interoperates with Jakarta as well. So there's some microprofile APIs that are the same as the Jakarta APIs. They make use of it. So it's kind of a mix of the two. So Jakarta specification and microprofile specification, both awesome open source specifications. You don't have to use them on OpenLiberty. There's tons, Pyara, Quarkus. There's loads of different implementations. So that's the nice thing, is by using these open source specifications, you aren't just locked into a particular vendor or platform or tool. It means you have that same flexibility and portability that we want when it comes to designing cloud native applications. So I would recommend checking out Jakarta EE, and also microprofile. As I mentioned, Emily's giving a talk on that later. So please do go and check that out if you want to learn more.
Awesome. All right, we have a couple minutes left. I just wanted to take note of one other thing that you talked about. When you were talking about telemetry, I was thinking about this time in the past. So I'm all about DevOps now, considering where I work with JFrog and stuff. And on past teams that I've been in, there has been this wall between operations and developers. And the result of that means that there were often times when I may have had a microservice in production that I didn't realize was having to restart all the time because I wasn't paying attention to deployment, right? So I loved how you brought that in, that's important not to forget the observability stuff after and observing your application and understanding what you need to do to change that.
I think people are so used to having applications that are either locally deployed or the ability to immediately introspect them. And that's not always the case when you have a production environment that's distributed in the cloud somewhere. So having that live observability, and also it's all well and good collecting it. You need to actually do something with it. That's the issue. So being able to utilize that data and analyze it as well is important. Yes,
totally makes sense. All right, this was awesome. Thank you so much, Grace. For everyone out there, enjoy watching this recording. I'll be watching it again later, get some reviews and taking some more notes. Thank you so much for sharing, and hope to see you at the next conference.